So hi everyone. So in this video I'm going to explain about operating system module 2. So what is mean by module 2 means process management system. So I'm going to explain process management in the module 2. So what is mean by process management concepts? So in process management there are several concepts. Process concept, the process state diagram, process control block, process scheduling in the sense scheduling queries, schedule operations and processes, inter-process communications, thread issues, scheduling basic concept, scheduling criteria, scheduling algorithm. So what is meant by process concept? A process is a program in execution. Process in the sense a process is execution. Process execution must process in sequential fashion. So you already know what is meant by processing. So processing nothing but the processing the execution of a programming. So an operation system executes a variant of programs, batch systems, time sharing systems. A process can be also included some of the programming counters, stacks, and data sections. In this process in memory, there are some of the program code which is sometimes known as the test section. This also includes the current activity as represented by the values of the program counter. A general procedure that includes process tags which contains temporary data such as functions, parameters, return addresses, and local variables. After that, the process has included the heap, which is memory that is dynamically allocated during process runtime. So what is memory process in the memory? So we have 0 to maximum numbers in a stack. So we have to heap the number, the data or a text, inserting in the stack. What is meant by process state? A process executes its change state. So while we are processing the program or execution, so it changes the state from one processor to another processor like that. So this process state includes that. Each process may be one of the following state: new, running, waiting, ready, temperature, terminated. The process have finished executions. So after the final execution, the process may changes to one state to another state. So this is known as process state. Diagram for the process state. So we have taken the new, admitting some of the process, and later we have ready the process. After there is interrupted like that, running, the waiting, schedule dispatch, input output or event completion, input output or event wait. After that waiting scheduling dispatch, that it will be run from the schedule dispatch to the terminator. After the running, it will be executed to the terminator. A two-state process models. So let me see, when you are entering into the dispatch, we will not enter. After we have entered, it will be pass or play in the dispatch. After the process has been done, it will be running outside from the exit. So this state is called state transition diagram. So now coming to the querying diagram, while we are entering into the process state, there is a query which is first in first out. So after entering to the query, the dispatch will be processed in an decision matter. After the process has been done, it will be executed from the dispatch. It will be repeated on entering into the first step. After it will be take some of the queries like that. So process control block PCB. So the PCB contains important information about the specific process, including process state, program counter, CPU register, CPU scheduling information, memory management information, accounting information, input or status information. So now we have to see the process controlling block PCB in a diagram way. The process state, process number, program counter, register, memory limits, list of the open files. So now see process scheduling. Process scheduling is nothing but the process in the activity of a process manager. How the process has been managed from one input to the output has been taken in the part of process scheduling. That handles the removal of the running process from CPU and the selection of another process on basic of particular strategies. Process scheduling is an essential part of a multi-programming operating system. Now the scheduling queries have job scheduling, ready query, device query. So in this represent the processing schedule while we are entering into the query, the CPU recognize the query and the CPU has been recognized the story. It will be continued to the next step, input output request. After the input output requested, the time slice expired and the child execution flow will be activated. Later the child execution has been entered into the ready query and then it repeated again and come to the wait for interrupted. After interrupted occurs, it again go to the ready query and enter into the CPU and will be executed the output. So this is the representative of the process scheduling. Now the CPU switches from process to process. So while we have process P1 to P1 from part 1 to step 1 to step 2, we have to move the processing. While we are executing this process, we have interrupted our system calls save into the PCB B0 means it will be entered into the reload state. After interrupted to that, it will process to the process P1. If the process P1 is idle, it will be again into enter into the save state in the PCB1. After it enter into the PCB1, it reload the PCB0. It will be executed the idle. Later, the process P0 to P1, it also executed from one part to another part. It takes some time to interrupt our system call. So what is meant by schedulers? Schedulers are the special system software which handles process scheduling in various ways, like long-term scheduling, short-term scheduling, medium-short scheduling. These are the three types of scheduling as been present here. So I will explain the comparative between the scheduling, long-term, short-term, medium-term. It's a short scheduling, it is CPU scheduling, is a process swapping scheduling. So what is different between these are the long-term is a short scheduling, and the short-term scheduling is a CPU scheduling, and the middle-term scheduling is a process swapping scheduling. Speed is lesser than shorter-term scheduling. Speed is faster about more 2 times. Speed is between the both short and long-term scheduling. It controls the degree of multi-programming. It provides lesser control over degree of multi-programming. It reduces the degree of multi-programming. It is also imports the offset or minimum in the system of sharing system. It is the part of sharing system. It selects programs from pool and loads them into memory for execution. It selects those processes which are ready to execute. It contains reintroduce the process into memory and execute can be continued. So this is the comparative between the scheduling. So now coming to the what is thread. It is the basic unit of CPU utilization. So a thread is a flow of execution through the process code with its own program counter, system, register and stack. A thread is also called a lightweight process. So this is a diagram while we are the between the process and the time. More, many software packages that run on modern desktop PCs are multi-threads. Example, a word processor may have threads for displaying graphics, another for responsive for keystrokes, and the third of the performing spelling and grammar checking in the background. So it indicates the threads. The word document is running against the threads. So threads have two types: single thread and multiple thread. How the single thread is been here in the diagram and the multiple threads have been here in the right side diagram. So the code, the data files are register stacks are same for both of them. So it contains only the single thread in the left side and it contains three threads in the multiple side. So it will be working as a multiple processors. It only want multiple working only one processors. Types of thread: user threads, kernel threads. So we have two types of threads: User threads and kernel threads. What is meant by user threads and kernel threads means user threads management done by user level thread library. Now coming from kernel threads supported by the kernel example virtual all general purpose operating systems including. So in this video I'm going to explain about the model 3 called concurrency and deadlocks. So what is meant by concurrency? Concurrency is the process of synchronization where process can be executed concurrently. Concurrent access to shared data may result in data inconsistency. Maintaining data inconsistency required mechanism to ensure the orderly execution of cooperating process. So the process can execute concurrently in this process synchronization. So let me see an example writer. Concurrently have two queries in one coffee machine. So two queries in the sense there is a two lines between these concurrent for one coffee machine. So the two lines of members can be go through this one coffee mechanism at a time. So it takes some time for this getting the one coffee mechanism. It is an inconsistent way. So while we are taking the parallel two concurrents in two coffee mechanisms. So one in this image can see that the one by one person can be go through to this one coffee machine and get the coffee. So it takes less time to execute this. So the difference between the concrete and parallel is as represented in this diagram. So now the process is synchronization. Let us see an example. While we are doing a bank transaction, initial amount of the account 1 is 500 rupees and account 2 is 0 rupees. While transferring amount process from account 1 to initial amount, let me see this. From account 1, we have transferred minus 100 rupees and account 2, we have credited 100 rupees. So account 1 into 10 and account 2 into 10. So let me see the process synchronization. So the amount has been cancelled from account 1 minus 100. The amount has been credited to the account 2 plus 100. So now the initial amount will be how much? So can you tell that? So now we have to interest the process. So from account 1 is equal to account 1 star 10 and account 2 is equal to account 2 star 10. So the process executed in the sense ends. So after before the execution the amount will be 100 for the account 1. After the execution the amount will be 1 from the 4000 and the account will be 1000. So it is multiplied into 10. So what is mean by process synchronization? So while we are taking the process A and writes into the data and that is read into the process B. This is means that it is possible that the data read by the second process will be synchronized or the producer process A will be get into the buffer and the buffer will be somewhat produce the data means it consumes some of the data into the buffer so it can be easily execute in that after the process has been taken from the process B. So I am now going to explain about the module 3 part 2 deadlocks. So what do you mean by deadlocks? So what are the contents have to be measured? What is deadlocks? Deadlocks with deadlocks. Deadlocks prevention, avoidance, and detection and recovery. So what is meant by deadlock? In this picture we have clearly mentioned that while the four junctions of the traffic has been executed in the one junction, so it will be traffic jam. So there is no way to go. So this means a lot for the definition of this name deadlock. So a process requires the resource the process are not available at that time. So the process enter into the waiting state. The requesting resources are held by another waiting process. Both are in waiting state. This situation is said to be deadlock. So have you understood this definition, right? So what is meant by deadlock means the resources are not available at that time. So the process enter into the waiting state. The requesting processes are held by another waiting process. Both are waiting state. The situation is said to be deadlock. So the resource 1 and resource 2 has been taken from 2 T1 to T1 to T0. So while we are entering the resource 2 and entering into the T1 and later the resource 1, uh, the T1 threads has a locked the resource 2 but requires resource 1 for finishing. And now the T2 thread has been locked on resource 1 but resource 2 has finished executing. So this is an example for the US kernel's law. So while we are both trucks are executing the bridge, so either one truck has been executed from right side or left side. So this means a deadlock is appear in this event. So deadlock possible in this image A1 deadlock. So image B2 is deadlocked. So the image has clearly mentioned like that. System deadlock. A process must request a resource before using it and must release the resource after finishing with it. A set of processes is in the deadlock state when every process is in set is waiting for the resources that can only be released by another process in the state. So now the system model. Resource type R1, R2 and RM. CPU cycles, memory space, input output devices. Each resource types Ri has WI instance. Each process utilizes a resource by following process request, use and release. So how to handle the deadlocks? Deadlock prevention, deadlock avoidance, and deadlock detection and deadlock recovery. These four steps we have to follow for handling the deadlocks. So now coming to this video, now we have to coming from the module 4 called as memory management and virtual memory management. So let us see what is the content have been in the memory management. Introduction, swapping, continuous memory allocation, paging, structure of the page table and segmentation. On the introduction, basic hardware address blinding, logical versus physical address, dynamic loading, dynamic linking and sharing libraries. So basic hardware in the main memory and register are only stored that CPU access directly. Program must be brought from disk into memory and placed into the process for it to be run. Register access is one CPU close or less. Cache sits between the main memory and CPU register. So let us do the basic limited registration for this process. So operating system has some of the process. So the limit is 120900 and the base is 3040. So let us see, we have seen that while we enter into this process, it limits 12090, but the base is 30440. So while we are executing this, the output of this process will be 1024000. So this can be dynamic relocation using dynamic loading. So if there is any doubt regarding this, you can go to this YouTube link. Swapping continuation, swapping diagram, and continuous memory allocation, memory mapping and protection, memory mapping and protection, memory allocation, fragmentation, paging, introduction, free frames, hardware support, protection, shared pages, structure of the shared pages, hierarchical paging, two-level page table scheme, two-level paging example, address translation schemes, three-level paging schemes, hash paging table, hashed page table, inverted page tables, segmentation, views of program, logical view of segmentation, segmentation architecture, virtual memory management. So virtual memory management defines virtual memory domain paging, page replacement algorithm, allocation of the frames, and thrashing. These five will be the subtopics of this concept virtual memory management. So we have a clear explanation in this PPT. So I have been mentioned this materials into the description of this video, so you can get into this. So page fault frequency and how the number of frames has been increased in this diagram. So this is the content for the virtual memory management. So for the module 4. Thank you. So now coming to the module 5 means file system interface, file system implementation, and mass storage structure. These are the topics has been covered in this module 5. File system interface. So file system interface means in the folder we have text files, video files, mp3 files, mp4 files, zip files. All these files are contained in this folder. So file system interface is the file is named collection of the related information that is recorded on secondary storage. So the file name can be edited by the user, but the files included in this folder has been stored in this file folder. So it acts as a storage between these files and the file interface. How the files and file systems are been arranged. So we can see different types of files has been here. So there are some of the folders, there are some of the zip files, there are some of the text files. So these are all contains the file systems. So what is the file systems can be routed. So let us example directories, bin, dv, etc libraries. On the file systems, usr, tmp, variable, and home. These are the file system interface types. So file system structure, file structure, logical storage unit, collection of related information. File system resides on secondary storage disk. File system organized into layers. File control block, storage sector consists of information about a file. So file system interface have file attributes like name, identifier, type, location, size, protection, time, date, and user identification, and how what is the storage has been allocated for the file to store the data. So all these attributes are in the file folder while right clicking to the properties. So this is an example interface for the file attribute. That name of the file attribute, permission, owner, date, and time has been taken on what is the name of the file has been mentioned in the clear in the image. So what is meant by file operations? We have some of the file operations like creating a file, writing a file, reading a file, and deleting the file. So these are 5 types come under the file operations. So file types. The number is split into 2 types: a name and an extension, usually separated by period character. So what are the file types? Means PDF files, zip files, PNG files, JPG files, MP3, doc, PHP, CSS. These all files are contained in the file types. So let us come into the access method. We have seen some of the access methods, several types: sequential access, direct access, and other access method. The name has been specified that for the sequential and other accesses. Means sequential means it will be jump from step 1 to step 2, step 3 to step 4. For the direct access, it will be jump from direct to the step 1 to step 2. So coming from the directory structure, The file system stores millions of files in the files folder like that. It manages all the files. You need directories to organize them. So file using these directories, we can access the file and manage the file, read the file, create the file, edit the file, and truncate the file. This device directory records information such as name, location, size, and types of the files that has been involved in this folder. So here see that a directory overview. So creating a file has been taken from user side, and this remaining are can be taken from the user side only. Deleting a file, list a directory, rename a file, traversal the file system. So now file system mounting. File system mounting in the sense while we are injecting a CD drive, pen drive of this into the system or PC or in your phones, the file will be mounted to get part available to the process by the system. That means while you are mounting this process, it will be mounted and can be accessed by the user to go through the folders, files, etc. So file sharing has multiple user system to describe. So while we are sharing this file, we have number of types of files. I mean techniques for sharing the files like NFS network file systems. So file sharing has a multiple users. It can using user IDs, group IDs for accessing the files. So now we have seen the Windows XP access control list management. So we have 10 properties for security guest PBG in laptop guest. So for the file system structure, this is the layered file system application has been present in this flowchart way. So the first one is application programs, a logical file system, file organization module, basic file system, and input output control devices. So for this allocation method, there are three types of allocation: continuous allocation, linked allocation, and indexed allocation. For continuous allocation, each file occupies a set of continuous blocks on the disk. Simple only starting location, block, and the length number of the blocks are required. So now coming from the free space management, need for free space management, limit amount of disk space. Need for free space management to keep tracking the disk space like that. So file can be creation or deleted for the free space management. Big vector listed, linked list, grouping and counting are the various space lists for the file space management.